On today's episode of Mailbag Sunday, or viewer mail, I got this care package sent into the channel from the owner of the den and deck that's been worked on here the past 2 or 3 videos. And what he told me was that he has a store there locally that stocks these and sells them, which is great. I don't have any stores in my area that have sold any sort of cassette for many years. These are imported from Indonesia, and I looked on the package of some others that I have, and they are made in Korea, or imported from Korea, is what they said, with, I think it said Japanese and American components. So this is great. So we put this little note on here: be kind, please rewind, and also included some pencils. And I didn't understand the connection, but he did tell me that the reason why is because these are Japanese pencils that he uses, and they fit the hubs of the cassettes perfectly, unlike our American pencils, which are a little bit smaller. So he sent those thinking that they'll be useful in the shop, and boy, will they ever. Steve, you don't know that I use these all the time, and I have electric pencil sharpeners spaced about every 15 feet in my shop. So thank you for that. I do appreciate it. I'm going to open one of these up and take a look at it, and I'll actually try it out on your deck. I do have your deck biased for the UDXL2, which is what you requested. But I'll try these out, and I'll do it in the next video. I won't do it in this one because I want to concentrate on the erase head, those dual gap ferrite erase heads. And I don't think there will be time on this one to do your calibrations and demonstrate the results on your deck. But that will be on the next one. So these are a little bit different. I couldn't find the tab, and they don't have a tab on the cassette itself, so we'll just open it up a different way. You know, Type 1 tapes on a deck that's been modified and upgraded and aligned and calibrated, they can sound really, really good. I would take that over a Type 2 tape on a deck that has never been touched. Really, there's a big difference on it. So there it is. It fits perfectly. Really perfectly. That's neat. I like that. So this is great. These are Mitsubishi pencils and an HB, which is exactly what I use. And I look forward to using these. This will be a great addition. And yeah, these are used every day in my shop. I converted back to the standard pencil from mechanical pencils for shop work a long time ago, just because the mechanicals break so frequently when I use the like the 0.5, which is what I use. Okay, so on to the meat and potatoes of this video. But this is the Denon with the erase head that I've already lapped once. I'm removing it to lap it again. I've spent the week and a half to 2 weeks following that last video, and the comments by, let's see, it was the SSTC was the commenter about the causes of the high frequency roll off on these ferrite heads. And there's a lot of information out there to absorb. And so I did a bunch of tests on 6 similar, I mean identical heads that I had in stock here, erase heads, And this is just kind of showing as I go into the next part of this video, so you can kind of orient yourself and visualize what I'm showing you. So I'm going to be going from left to right. This is the head out of the Denon. Now it's been lapped again a second time using a completely different procedure, different abrasives, and I can talk about that a little bit, but I chose to leave the actual lapping part out of this video because I don't want to encourage it. It was a learning experience. There are some very specific methods that I used, and I also ended up power lapping these on a machine that I modified to lap carbide with, and I remodified it to do this with a diamond lapping film. This is 1 micron, and it also has the ability to use flood coolant, which is absolutely mandatory, as I discovered anyway, with my method. Mist coolant doesn't work. It's absolutely mandatory to use flood coolant, very slow speed, and very, very light pressure. And so, just to refresh, this is the video from the former lapping job. This is post-lapping on the Denon head, erase head. And I had mentioned that, and I did do quite a bit of testing on this, I'll talk about that later, but I had mentioned that the main difference I saw were fewer pits and rounded over edges compared to the unlapped head here. And based on what SSTC posted about the induced eddy currents doing the erasing, I still believe that this was helpful to have these edges rounded over like this, to not have such a sharp point of demarcation on the pits and the gaps. So I think that was helpful. According to my tests, it was helpful. Also, the lubricant, the ceramic dry coat that I put on, I believe was also helpful. But so this was the head before, and this is the newly lapped head. After, like I say, a week and a half of research and testing every night and teaching myself how to do it, basically. Also, there's some great information on JRF's website about these heads and lapping in general, and I would encourage anyone dealing with this to spend some time. They have some downloadable documents. There's a lot there. So this is what, like I say, the final product ended up looking like. And you can see especially those outer gaps are much cleaner than they were with the previous method. And based on the information over at JRF, he does refer to oxide stripping, and I believe that that is still possible, that there's some of that taking place. So I'm not discounting that entirely. I think there might be both the eddy current creation and the oxide stripping. The oxide stripping is evident just by the debris that's on the heads after a few hours of play. So it's shedding from somewhere, and let's just call it that I think both of these probably contribute to the high frequency roll-off. Okay, so let's go through each of these and I'll explain what I did and what's going on with them. So the first one here, farthest left on those larger heads, this is the untouched head. This is just a brand new one out of the box. And this is what they look like. Obviously the surface finish is much coarser than mine, but the pitting is, there are some large ones, but mostly small ones. And it doesn't look too bad. Now what I'm finding is a lot of inconsistency in these two, and I'll demonstrate that. but there's what it looks like. It's typical of a porous material like this. And of course, I'm assuming, or I'm maybe deducing, that the gaps have to reach a certain size, or the pits have to reach a certain size for those eddy currents to be able to be formed. And this is how metal cracks are tested also, and that's why they can be tested, because they are of a certain size, larger than the base metal. So I don't think the small pits are any kind of a problem. I think when they start to break down and the gaps start to break down is where the problem is created. Now this head here is also a brand new head, but I just did the standard ceramic dry coat that I typically do on heads anyway. And I was curious to see if it would, under magnification, fill any of the gaps, if it would actually stay on the surface and maybe bridge some gaps, and it absolutely does. You can't see it as well in two-dimensional view on the camera sensor, but in binocular view, it's very obvious that there is thickness to those dry lube particles. So again, I'm thinking that the tiny amount of space off of the head, the lubricity of the product, and the small amount of filling the pits contributes to the lessening of the high frequency roll off in my tests with Steve's deck. So I still think this is a good product, but I've changed products, and I'll show that towards the end of this. Okay, moving on to another just random head picked out of the box. I want to show the difference in this one. Now look how much coarser and rougher and larger pits, and these are same order, same box, same part number. Just completely different character on this head. So a guy could put the first one in and maybe everything will seem okay. He might put this one in a different deck and this one's not okay, and without looking at it, how would I know? So seeing this now, I wouldn't put this in a deck, but the other one is not bad. Probably would have worked fine for quite a while. So just showing the inconsistency there. Okay, now comparing those to a lapped head, and I think this was my first attempt at lapping. Now I'm going straight to 1 micron on these. I'm not working up to them. That didn't work. Using the coarser grits and working up to this caused much more pitting and much more breakdown than just starting out with the finer grit with flood coolant. Now the coolant I was using was distilled water with some IPA, no percentage or anything, just a splash of IPA, and a few drops of dish soap as a wetting agent. EDTA would be better if you don't want the little bit of suds that happen. It's not much, but on the power lap there is some sudsing that takes place. So this is obviously much cleaner all the way around. And I would be perfectly happy with this, obviously. This one was lapped the same, with the same procedure, same everything, using just a little bit less pressure. And the way I can kind of describe the pressure is like I'm trying to create hydroplaning. It's just the tiniest amount of pressure that I can put on. I mean, the weight of the head is about, all that's there. And so this is just another second practice head, and it's consistent. It looks similar. So I think I'm happy with the procedure and the grit and the lubricant. And there's what that one looked like when I started. Now this one, interestingly, I did the same thing. I started out with 1 micron, and then I moved up to 0.3 micron. And this has some scratching in it. There's no finer porosity or gap breakdown, but there are some scratches in it. And those scratches are, I believe, because there was inadequate coolant flow to flush the particles completely away. And I don't see any benefit to moving up to this finer grit where there is a risk of, like I say, not being able to fully flush those particles away. Because that's not grit scratching, that's particle scratching. Obviously, if it was grit scratching, it would be different than that. I'm just looking at these again. I find these fascinating. What I think I'm seeing now, as having it lapped finally and being able to see it clearly, I think these are probably something like a microballoon in that potting compound in the edges, is probably what that is. And, they certainly look metallic. I'm just fascinated with them and just having a little fun showing them. So if there are any material science engineers watching and would like to explain this, please do chime in. I'm all ears. Okay, so I'm just going to change my lighting here a little bit and see if I can show these others in any more of a better contrast. Let me see if I can find that coating again. Yeah, I think it probably didn't really change much. Okay, so let's move on from here. One of the other things that I spent some time researching is coating these heads. I looked at several possibilities, including, vapor deposition. I looked at zinc. I looked at different methods that people are experimenting with, laser deposition particles. And what I decided on after all that was this graphene enhanced ceramic coating by Alpha. And this is their marine grade product. I chose the marine grade over the aircraft grade because their marine grade product contains graphene. And graphene is highly conductive. And my reasoning is that it's also, of course, very small. And I believe that it will fill those gaps, or not fill them. It should bridge the gaps with a conductive material that I reason will prevent the creation of those eddy currents. And this is an extremely hard product with very high lubricity also. And I believe that that will also cut down on, number one, on the wear, but it will cut down on the breakdown of the pits of the ferrite, creating larger pits and causing more problems. So that's my reasoning. This is also something that in a marine environment they say should last 2 to 5 years. So that's encouraging. So I know that's upside. This isn't sponsored. I bought this stuff, but I'm just showing you because it was upside down there. Now, their stated procedure is to shake the living hell out of the bottle for a couple minutes, which is what I did. Apply it to the sponge, and then go a couple different directions. And then basically let it dry for a minute or two, and then not polish it off, but kind of rub it in using microfiber cloth. So this is freshly lapped. All I'm going to do is just clean it quickly with IPA. This is just a lens cloth that I'm dedicating to this. Now they want 24 hours drying time on this, and I'd like to get 2 or 3 coats on, at least 2. And so this will be an application, and then this will sit for 24 hours, and then I'll do another application before and that's one of the reasons I don't have time to do any of the tests on this deck, on this video. But that's okay. I think this should be a pretty good test. It will be valuable. On previous lap job on this head, I used a TDK-D, a Sony Type 1, and then also the UDXL2 Type 2 that I biased the deck for. So I've already had this head in and done multiple tests of frequency roll-off, high frequency roll-off. I did the tests at 15.5 and 20 kilohertz. And what I found on the first test was on the TDK-D Type 1. I made 14 tests on that, and I averaged the first 3 playbacks against the last 3 playbacks, is the way I did it. Now, reading through the forums, I saw that some people were using the monitored signal during recording as their baseline, as their reference, which is incorrect. And that was also pointed out by some other posters later on. I've done actually many videos on this showing exactly that process. So the correct way to do it is to make the recording and then play it back and use that first playback as the baseline, not the monitored recording. Even though some decks have spacing between the record and repro head, and that's acceptable, I still think for the purposes of what we're doing here, that it would be better to just use the first actual playback rather than the monitored signal. And they were getting some pretty impressive reduction with this head. After I did the first job and coated it with ceramic a couple of times, I was getting statistically insignificant difference between the first group of 3 and the last group of 3 averaged. On the Sony tape, it was a different story. And now what I read was the Sony was the most susceptible, and I got a 2 and 3, 2 on one channel, 3 dB on another channel, on the other channel, roll off after 10 plays. First one was 14, the second one I did was 10. The third test I did was with the UDXL2 10 playbacks also, and I think I did this one twice, and I got about 1 dB roll off on that, and I don't even know that 1 dB isn't normal. Okay, so now after 24 hours, I wanted to put this head under the microscope and see if I could see anything at all, if I could see the coating at all. And those streaks that you're seeing there, those dark streaks, are the coating. Those aren't scratches. That is actually the coating. And again, in stereoscopic view, it's very, very obvious. Those are almost like shadows, but I can see a buildup. No question in my mind that there is product on the surface of that head. And of course, I expect graphene molecules to be filling all of those pores. So I have a lot of hope in this procedure. I really think it's going to help out. I would like to find, there are different coatings that could possibly be done on this, but it would be an outside job. It would be time consuming, and it would also be expensive to have 1 or 2 or 5 or 10 heads done, PVD coated somehow, zinc coated, something like that, and then, you know, relapped and so forth. So I have hopes that this will work. I will give it 2, maybe 3 coats and make a bunch of tests, and I'll do the tests with the deck on film so you can see exactly what I'm seeing. This deck is all but finished. It's been calibrated, aligned, rebuilt, recapped, and it actually sounds fantastic. And of course, I've been talking to Steve this whole time about what I've been doing, and he's kindly offered to let me keep this as long as I want to run these tests and make as many videos as I'd like. So I wanted to do this on a deck that's been fully overhauled and I know is operating correctly. Trying to measure tiny signals on a machine that's not hitting on all 8, well, that's really not very helpful. I'm just going to have a good look here and document this. All this is for my own information as well. Making videos of things, it can be really helpful sometimes. Be able to go back and see exactly what you did. It's a good thing. Okay, so I just wanted to see if maybe I could show you before I put this back in what this looks like to the naked eye. This is just an absolute mirror when you're not looking at it under magnification. I'll go ahead and put this back in the deck and do the second coat in the deck. And then just while I have it out here, measure the inductance. Now, I was thinking it might be a helpful thing to scope the head while a tape's running over it. You know, just disconnect it from just disconnect the leads and scope it. If that eddy current is being created, you know, a good scope should be able to pick that up. I think that would be a good, valuable test. Okay, we're back in here. Shake the bottle up again. And I'll just give it one more coat in place. I'll just work through the bottom opening of that door. And Steve, what I'll do is I'll find a little bottle or something and include a little bit of this product when I send the deck back to you. Maybe once a year or so, you might want to put it on yourself. Now, I used a regular swab here, but I didn't think. I actually had some foam swabs that I should have used for this because it's more similar to the product that they provided with it. It's actually identical to it. This will be fine for the second coat, but on the other ones I would use those foam swab, and then that will be consistent with Alpha's instructions on this. And we'll let that sit for a minute or two. I've got my little egg timer here that I'm supposed to use for knowing when the camera will shut down. 20 minutes, I think, is what they... The thing is, you have to look at the timer to know that the camera is about to shut down, which I'm not very good at doing. Yeah, just wrap a clean swab with the eyeglass cleaner. And what in the instructions, what Alpha's asking for is just a microfiber cloth. So this is microfiber cloth. Just that simple. Anybody can do it. And hopefully this will do it I need it to do. I'll be making some tests that will probably post next week. I'll be doing that through this week. And we'll see. We'll see how all this turned out. As always, I thank you for watching, and I look forward to posting the tests of all this on the next video. See you soon.